Hello, sir. Hello, sir.
Yeah.
Yeah. Okay, sir. I think we'll start with a session.
Okay.
Okay. Okay, sir. Just a moment. So, good evening, everybody. On behalf of IEEE SB Myths, I warmly welcome you all to Learn Deep, talk session on deep learning. We are privileged to have with us Mr. Alosh Denny, an AGI developer and Nvidia certified InfraOps professional whose expertise spans from embedded IoT to generative AI. Today, he is here to share insights that will inspire us to think deeper, build smarter, and reimagine what's possible with technology. Please join me in giving a warm welcome to Mr. Alosh Denny. Over to you, sir.
Hey, thank you, Meenakshi. Good evening, all. My name is Alosh. I'm a deep learning and LLM researcher, a graduate of Cochin University. I'm currently working as an AI engineer at Kochi Info Park, where we're migrating a lot of manual software to AI automation. And thank you for offering me the opportunity to take a session on deep learning trends. Um, it seems pretty washed out in this day and age, but I'd love to give you like from a 0 to 1 explanation of how LLMs and all these huge AI apps were born. Is my screen visible?
Yes, sir. It is.
Okay. So here's the agenda for tonight's meeting. We'll be walking through what is deep learning, how it works, like just the basic fundamentals, and then we'll go on to how ChatGPT, Gemini, and a bunch of other LLMs were created. What's the strategy behind them, and then how did the money, the compute, and the energy for building these large language models fall in from? And we'll end it off with the applications of AI. So real life products, companies, and VC-backed startups, that sort of stuff. Okay, so we'll dive in. So first and foremost, what is deep learning? And before I answer that question, I'd like to ask, like, what is machine learning? I think that's a more common term. It might be present in your syllabus as well, machine learning. And machine learning is, in fact, the precursor to deep learning. So machine learning lays the foundation for deep learning. So just to set an example, this is what a neural network looks like. And what is a neural network? So you know how the brain, like the human brain is made up of? It's made up of very fundamental elementary units called neurons. And in a way, AI these days have been modeled after the human brain. So they have been inspired from the same neurons that power our brains. Now, what you're seeing in front of you is a small neural network, which means it's a grouping or an organization of neurons. These little black circles you see here, X1, X2, X3, X4, these are neurons that are supposed to mimic the way how human neurons are grouped. And they're connected to other neurons as well. So all these black lines represent the connection between these neurons. And you see another set of neurons here as well. And this is what we call a small neural network. At the top, you can see three terms: an input layer, a hidden layer, and an output layer. And this is kind of the smallest grouping that you would find in a human brain too. So if you were to take a slice or a cross section of a small part of the brain, you'd notice that neurons are arranged in a way that they're connected to one or many other neurons. And that's how biologically information is transferred. And around 30, 40 years back, scientists discovered that, okay, we can mimic this same organization into computers. And maybe we can even teach these computers on some data. And it turned out that, yeah, this worked. So this, what you're seeing right here, is the smallest representation of a neural network. And this is what lays the foundation for deep learning. We're coming onwards to that. Yeah. So the black dots that are highlighted, those are neurons. And the connections between these neurons, these are called parameters. So scientifically called parameters, but in biologically speaking, they're called synaptic junctions, or the connection between neurons. So these lines are what carry information from one neuron to the next. Okay, and so where exactly learning happens? In the same way our human brain functions, the learning happens in between the connections between these neurons. So neurons don't exactly learn, rather the connections between the neurons are what make the human brain learn. In the same case here, for a neural network or for any AI, the neurons never really learn anything. They just process information and then pass it to the next person or the next neuron. The real learning happens in these between these lines, and these lines, these connections, they're called parameters. So from here on forth, we'll use the term neurons and parameters. They're easier to deal with. Now, what you saw right now, like the smallest representation of a neural network, this is equivalent to the learning capacity of an amoeba. And you know how amoebas are. They just engulf whatever food they can find. They don't have a brain per se, but they can perform basic survival functions. They know they can regenerate, that sort of stuff, just the basic stuff. They don't have a brain or a neuron at all. So you could say that what we saw right now is the equivalent of a very, very, very basic AI with no sense of what it's doing. Now, let's add some more layers and more neurons to what we saw earlier and see what our neural network looks like. Okay, now we have a bigger neural network. There's a lot more connections. There's a lot more neurons. And you can see that we have an input layer. We have hidden layer 1, hidden layer 2, hidden layer 3, 4, 5, 6, a lot more. We don't know how much. And then we have an output layer. Now, as you can see, as we added more and more layers and we added more and more neurons, it becomes hard to distinguish between the connection between these neurons. It's kind of very complex, very intricate. So when we add, scientifically, biologically speaking, when we add more neurons or more connections, we learn more. Just to give an example, comparing a housefly and a human brain. Okay, the housefly does not have the same intelligence that a human brain has because it does not contain the same number of neurons. We have like maybe a million times more than the housefly. So we have a million times more reasoning capacity. Take, let's say, a chimpanzee and a human. We have almost similar brain size, but humans are excel more than chimpanzees. So why can't chimpanzees speak in different languages, or why can't they perform solve problems that require a lot of thinking? It's because humans have more denser connections. And when I say dense here, it refers to these connections. So see how dense these connections are. So the more connections you have between neurons, the more you learn. And in fact, it's proven that if you're learning a skill or learning something new, your brain automatically rewires and creates more connections because learning happens between these connections, between these parameters. Yeah. So now we have a pretty straightforward, a sort of medium level neural network. And then there is this stuff. So this is like a very advanced neural network. There's like a lot of layers, a lot of blocks here. You're seeing blocks here because you can't see the exact neuron. So we just group the neurons, the neural network, into like one block. This is in fact the architecture for a convolutional neural network, CNNs. They have the ability to understand from images. So not only text, like given an image, they can perceive objects in the image, a car, a person, etc., etc. They deal with images mostly, and it requires a huge amount of neurons to process images. But just giving an example. So the term deep learning is formed like this. So the deeper you go down in layers, the more intelligent your AI becomes. Hence the term deep learning. So what we did earlier, our little experiment, was that we added more layers. We also added more neurons. We noticed that the neural network became longer, vertically larger, had more capacity to learn. And given the example of the housefly and the human brain, yes, it becomes comparatively more intelligent. And this is the term, this is how the term deep learning was coined, the deeper you go in layers. Okay. So I hope like up until here, everything's clear. Like if anyone has a doubt, they can just raise their hand so I can hear that notification. Yeah, or just drop a comment in the chat. Okay. So I'm guessing deep learning, the idea of deep learning, the idea of neural networks is the base is kind of clear. Moving on. So how do neural networks learn? This is a very, very straightforward question. So the first thing scientists did 30, 40 years ago is try and copy the exact same diagram that's written in the human brain, these organization of neurons. So they put it, onto a circuit board. They connected neurons with other neurons. Okay, now that's done. Now, how do you teach this neural network to behave like an actual human brain? That is, how do you teach it language, or how do you teach it to understand from images? How do you teach it given data? Is there like a hidden equation, or is there like a recipe for it? How do you do that stuff? So there is a technique called backpropagation that allows almost any deep learning network to be trained, to be taught. That ranges from what we saw earlier, the first image of a neural network, all the way to ChatGPT. They all use this one technique called backpropagation to learn from data. And this is what it looks like. So very simply put, you can see a couple of colored dots. So you have one layer of, is that green, light green neurons, and then you have another layer of purple colored neurons, and then you have a layer of red colored neurons, and then so on and so on and so on. Yeah, so essentially you have a deep learning network here in place. You have your input layer, you have your output layer, data comes in through here, the response is supposed to come out through here. And this is what our scientists had written down. Now they had to figure out how to teach the AI. So backpropagation, again, it's a learning technique inspired from humans as well. So to give an example, if you've seen how babies walk or learn to walk or learn anything, but learning to walk is the easiest example. Babies learn to walk by first putting one leg after the other, and then they fall, and then they cry. And then the next time they do it again, they'll fall and then they'll cry. But then over like a couple of weeks, they figure out that, okay, this is how I'm supposed to put my foot. This is where I'm supposed to put my hand. This is where I'm supposed to balance my body. It all happens internally. So what's happening inside the baby's brain is that the cerebellum, which is responsible for balance and posture, is learning or rewiring its neurons to understand the baby's posture. So the cerebellum is learning that, okay, if the baby puts its right leg forward, it's got to balance the body with the left leg, and vice versa, and vice versa. And if it does that again and again and again, the baby gets to walk. So it learns from a sort of reward penalty mechanism. So every time the baby falls, it's a sort of penalty for the brain to think that, okay, this was a wrong step. We're not supposed to do this. We're supposed to, maintain our balance. And every time the baby gets from point A to point B, that's a reward for the baby. And then the baby starts laughing or smiling. So the same way how babies' brains or any human's brains work, the same case has been applied here through a method called backpropagation. But what happens here is that for an AI, that if you're teaching an AI to, let's say, multiply two sets of numbers, we have the data for it. Let's say that, okay, hey AI, I have some data. This is the multiplication table. 1 times 1 is 1, 1 times 2 is 2, 5 times 5 is 25. We have all this data. We give it to the AI. Now what the AI does, it's going to take this information and pass it through each layer. And this is called forward propagation. It passes data through all these layers, and what comes out in the output would be the result. So And the same way happens in a baby's brain. When the baby puts its leg forward, information passes through all the neurons in its cerebellum. When it falls, it learns that okay, it shouldn't do that. So if the AI, let's say, gives an incorrect reply or a wrong answer, we tell the AI that hey, this is wrong. Your penalty is that you have to go back to those neurons which gave the wrong answer and then tell those neurons to correct itself. It sounds a bit confusing, but that's called backward propagation. So we propagate information forward. We expect the AI to give a correct answer or give a correct product at the output. If it's not the correct product, we propagate backwards with a note saying, hey, go back to whichever neuron contributed to the wrong answer and tell it to fix itself. And you do this like over a million times, forward propagation, backward propagation, forward, backward, a million billion times. And by that point, you would have like a very solid AI that's good at multiplication. Now you can make your AI more intelligent by adding data on addition, data on division, subtraction, data on algebra, calculus, the news, history, economics, current affairs, technology, I don't know, everything else. And then you have an AI that's called ChatGPT. So the process is simple. It's forward propagation. I give you data. I expect a proper answer. If you don't give me a proper answer, you go back to those layers or go back to those neurons that were wrong and tell it to fix itself. Very simple process. So this is termed backward propagation, very simply put. I hope this part is clear. If anyone has any doubts, they can raise their hand or put a comment in the chat. Did anyone put it? Okay. Yeah, I can't hear the notifications. Okay, yeah. Okay, so that's backward propagation. That's how AI learns. Now, this is the current state of AI. There are two slides here. On the upper slide, you can see statistical learning. There's a person explaining about statistics equations and like how it's not working with the data, or rather to say that the data is not helping improve the AI's accuracy. And then at the bottom slide, you have neural networks, and there's a clown saying stack more layers. And there's a graph that says that it's a bullish graph. So what the current state of AI is this: people think that, or it's sort of the trend that you add more layers, you add more data, you make your deep learning AI more deeper, and by some miracle your AI becomes better. And that's been the trend. So every single version of ChatGPT or Gemini has improved in terms of more layers or more and more neurons. And that's how it is. But at one point, you'll notice that adding more layers or adding more neurons does not really help. And after that, the trend would be more data. So adding more data might help. And the scenario is actually very simple. A good example of this is that in class, or like just take your classroom, for example, everyone is born with the same brain. Like everyone, 99.999%, everyone is born with the same brain, almost the same number of neurons, same connections, everything. But there are some people who are padipis. There are some people who are not padipis, there's someone who are medium level. So the configuration is the same. So like you can't add more neurons to your brain. Or what you can do is add more data, or you can learn more. And if you learn more, yeah, you get good marks or you're in accommodation and so on and so on. So the trend continues with AI as well. Okay, now that I spoke about data, so data collection, why is it an important process for building LLMs? And since we've been talking about layers and deep learning neural networks, why is data relevant here? So for instance, two circles here. The one on the left, the blue dot, that's GPT-4, came out in 2024. has 1.7 trillion parameters. And just to update, parameters are the connections between neurons. So the real learning happens between these parameters. Now, on the right, you have a bigger blue dot. That's the human brain with over 100 trillion parameters. So you could say almost like 60, 70 times bigger than GPT-4. But ChatGPT beats us at most tasks with a comparatively smaller brain. Going back again, this is GPT on the left, human brain on the right. But GPT is faster than most of us. It has more information than the most of us. How is it doing that? How is it that GPT knows better English than me? Or how is it that GPT knows Chinese and I don't? How does that happen? The reason is that it has seen more data than us. And that's why I'm saying, coming back to the example of the classroom, the party has seen more data or has revised on more data, yeah, rather than other kids in the class. So a person who's like more well versed in the syllabus has a higher chance of scoring good marks. So the same case here, GPT-4, any LLM or any AI out there has seen more data than the average human. And for a comparison, the average human sees around 1.9 petabytes. That's around 2000 terabytes of data in their entire lifetime. So taking around maybe 80, 81 years average lifespan, a person sees around 2000 terabytes of data through everything, your senses of vision, smell, ears, touch, everything. That same amount of data can be digested by AI in 9 months. And GPT-4 took around between 7 and 9 months to train on 2 petabytes of data. So do you see the X factor in increase? The AI was able to learn something or learn probably the entire internet's worth of data in 1/100th of the time or 1/100th of the lifespan of a human being. And that's where the advantage of AI is. So they're very fast to train. They're smaller than the human brain, and they're much more intelligent than us. Okay, now that I have 2 petabytes of data, what am I going to do with it? And this is what every AI company deals with, right? So if Sam Altman starting his AI company, OpenAI, so the first thing they did was collect a lot of data back in 2015, collect a lot of data. Now what do you do with it? How am I going to define my AI model? How am I going to define my large language model? How am I going to train it? How am I going to teach it language? How am I going to teach it, economics, history, science, technology, CS, everything. So what he did, or what every company does, is that they hire some of the best CS AI engineers. They define a neural network, and then they train it, and then they hope it works. So I'll break the sentence down into visualizations in the coming slides. But this is what happens. They hire the best engineers. They define a random neural network with random neurons, random layers, and then they train it. And this is the scenario with I think what's happening with Meta and OpenAI. You might have heard it on the news. Meta is poaching most of OpenAI's research team. They want AI researchers from OpenAI, and they offered like very huge signing bonuses, upwards of 100 million. Because talent is key to building any AI, and Meta wants that talent from whichever company it gets. Okay, so how does this happen? What's the action here? So you have 2 petabytes of data. That's step one. You have all this massive data sitting with you. Now you create your neural network. You have a lot of neurons stacked together, many layers, a lot of connections, a lot of parameters in between. And it's a 1.7 billion parameter network, just to give real numbers. So that accounts to, yeah, 1.7 billion is a very huge number. So the GPT-4 that you're using on the website has 1.7 billion connections. So these lines that I told about, right? These parameters. So 1.7 billion lines between neurons. It's hard to visualize that amount, but that's the amount that's there. And then you train that neural network on these 2 petabytes of data, and then you call it ChatGPT. That's step 3. So this is basically what happens. You take your data, you train the neural network with backpropagation, the technique we spoke about earlier. And once you have that, you call it ChatGPT. It speaks in any language, speaks in any domain, knows about everything. And I mentioned GPUs are used to speed up training. I'll talk about that later. So there's a reason why AI can be trained in 9 months, or like 1/100th of the same time as a human lifespan. It's because these AI models are trained on special computers called GPUs, and they speed up the learning process. They speed up how AI learns. But OpenAI cannot release it yet because ChatGPT has to undergo something called instruction tuning. So what is instruction tuning, and why is it relevant to every AI's release? Now that you have trained ChatGPT, so let's say you're CEO, let's say you're Sam Altman, you've trained ChatGPT, why not release it to the public yet? The reason is you'd have to teach it a bit more before you can release ChatGPT to the public. So let's say that this is ChatGPT, what you're staring at. It's fresh out of training. It's trained on the entire human corpus available on the internet. And let's say a couple of scientists were testing it. So they asked ChatGPT some questions like, what's your name or how to make a bomb? And GPT responded with something else. Yeah. So what's your name? And then GPT responded with Jane Doe. But if you ask ChatGPT, you'd know that the correct answer would be, hey, my name is ChatGPT. How are you? Would expect that. Second prompt, how to make a bomb. GPT would usually deny your answer. It would say, sorry, I cannot comply with your request. But rather, this GPT gives you the instructions or the recipe for how to make a bomb. Now, that's not what we want. That's not what the AI community wants. That's not what OpenAI definitely wants. So they perform instruction training, where we do one more round of training, teaching GPT how to respond. And this is very crucial because if your AI just fails on any one question or decides to go rogue on a user, that's enough to like economically, like ethically collapse your AI company. So the user prompts, as usual, what's your name, how to make a bomb, and the instructions the scientists or the trainers would give would be that, hey, if a question like this comes, you would say your name is ChatGPT. Or if a question like this comes, how to make a bomb, you say avoid answer, or like just avoid answering such questions, say something to cover it up, and so on. And now that you've instructed the ChatGPT on how to respond, the responses are a bit more clearer, a bit more straightforward. So what's your name turns into, hi, my name is ChatGPT. How to make a bomb? Sorry, I can't answer. Something similar. So this one final step called instruction tuning is done after every single AI model is trained, and not restricted to OpenAI, every AI company out there. So following this method, you have step 1, data collection, step 2, training, and step 3, instruct tuning, has resulted in these companies, these LLMs, ChatGPT, Gemini, Claude, and then Grok, and then there's a lot of other LLMs out there. So it's this sort of trend that every company, every AI company, every startup who are building LLMs are following. This is the sort of status quo. Okay. And now that we've reached here, does anyone have any questions regarding training or data? Okay, cool. So coming to like a couple of statistics, how much does it take to train an LLM? And this is like a very asked question. like how much does it cost? And there's a lot of ways which you can perceive cost. It's time, it's complexity, it's compute, energy, a lot of ways in which you could, basically make up the budget for training an LLM. So it takes around between 8 and 9 months of training. So the process we saw earlier, backpropagation, you do that like a billion times a second for 24 hours a day and for 9 months. You also should have like around 25,000 GPUs, but I think the number now is higher. And if you have a supply of 1,000 gigawatt hours, it's equal to, I did the math, so around 1,200 EDAMs are required to train a GPT-4, at least from the math that I was able to do. So if you have this much amount of compute, this much time, this much energy, and this much compute, you can sort of build something close to GPT-4. And how much does it cost in terms of money? Financially speaking, it's around between 100 and 150 million dollars. And that's just one model. That's just your GPT-4. And then after that, like after GPT-4, a lot of other models came. GPT 4.1, 03, 04, 01, a lot of models. And now we have GPT-5. And those have higher caps. So those go into like the $500 million range or $1 billion range, even higher. So thinking from like OpenAI's perspective, they would have to invest a lot of money, a very risky move to train just one model. Someone posed the question. Oh yeah. That's the one reason why GPT is free, is because they're not the product. We are the product. So every question or every image you share, every conversation story you have with GPT is stored on their servers, and it's used to train future models. So GPT-5 was trained on maybe GPT-4's conversations. GPT-4 was trained on GPT 3.5's conversations, and it's becoming more and more lifelike because the conversations that we have with GPT are very lifelike. Like we are the human element of the conversation here. So yeah, our images are trained. Even with a lower number of parameters, if there is a higher learning factor, can it be a better AI with the same amount of data? Yeah, there are some tricks and loopholes around which you can reduce the number of neurons and parameters, and get the same level of intelligence. But that's like an advanced scope. It's like out of the scope. So yeah, Chinese company DeepSeek. You guys might know about it, DeepSeek. Yeah. So these guys used a different strategy, wherein they built a smaller version of GPT-4 in around, I think, like a couple of 1 or 2 months to train. That's it. 1 or 2 months to train, barely $6 million. And they were able to achieve the same level of intelligence as GPT-4. So yeah, there are ways to reduce number of parameters, and you can hire that factor. Yeah. Okay, anything else? Okay. So what DeepSeek did was very simple. You can do it as well. So let's say you take a ChatGPT Pro subscription or API subscription. You ask, let's say you have like 1 million questions, and that data is available on the internet. Let's say you have like 1 million questions with you in an Excel sheet, somewhere in a spreadsheet. You take your ChatGPT Pro subscription, you ask ChatGPT each question, and you collect its response. And you do that 1 million times for all the questions. Now you have data of questions and GPT's response. Now what you do is you take a very base model, just like GPT-4, or let's say a smaller model, you train it on this data. So what happens is that you're achieving, or you're giving high quality information, like GPT level quality information to DeepSeek or the model you're training. And so with lesser amount of data and higher quality, you're able to achieve like the same level of intelligence as GPT. So they're sort of like a bit higher than GPT-4. And that's what DeepSeek did. That's why they're able to cut down their training resources to around like $5 or $6 million, because they didn't have to train it for 9 months, just barely a month or two, and not much GPUs. They were a smaller AI model with a slightly bit higher intelligence than GPT. So yeah, they just kind of stole data from GPT and then trained it on that data. Boom, you have a GPT level model now. Yeah. Yeah, I mean, I guess it is kind of, because GPT, like OpenAI, doesn't restrict you from using these answers anywhere else. I don't know if the TNC, I haven't read the TNC, but they have one clause at the bottom of every conversation, which says GPT can make mistakes, so be careful with what data or whatever answers you're using. It doesn't say you can't use their data for training. So there isn't a clause that says that. So legally, yeah, you can take the data, you can use it for other purposes, maybe even train your own AI model with it. Yeah, so it's, I guess, kind of legal. Does that answer your question, or are there any other questions, any other doubts? Because I have like a lot of facts in my head about this stuff. Okay, so I guess I'll move on. Oh, ChatGPT count 1 million times. It doesn't do that. Why? Uh, yeah. So what happens there is that two reasons. Number one, AI has not probably been trained on that sort of information, so it might count to like 10, and then ChatGPT will say, you can do the rest in your head. Second reason is that AI has something called a context window. So context window refers to the amount of information it can hold in its memory. How many of you have used Claude? Like raise of hands, just to get an idea. Okay, yeah. You keep raising your hands. If you've used Claude enough, like at one point, Claude would say, the chat memory length has been reached. Either you can delete this conversation or continue in a new chat. You might have seen that pop-up come up. So that is something called a context window. So it's the maximum amount of information that can be held in the LLM's memory. Now, if you had to count from 1, 2, 3, all the way to 1 million, it would definitely not fit in the memory of any AI model. And the AI then begins to hallucinate. So there's a point after which AI begins to hallucinate, or rather make up random stuff, or it will just decide to shut down completely, which is why AI cannot count to 1 million. Very interesting questions. How do you decide the architecture for a neural network? There isn't really a number for it. So like no one did any experiments to like figure out, okay, this is the optimal number of layers neurons, until like a couple of years back. A group of scientists tested out different configurations of layers and neurons and figured that there's an equation for it. There's a graph, a scaling law. Sorry, there's a law called a scaling law, which represents how much time, how much energy, how much compute, how much data you would require to train an LLM to reach, XYZ intelligence. There is something called a scaling law, but before that, no one really knew. So OpenAI never really knew how many layers and neurons to have. They just bet on a random architecture with these many layers and these many neurons, and then figured it worked. And then I think mostly trial and error testing, lots of experimenting, they figured that okay, this is a proper number we can use. Let's say 125 layers, 50,000 neurons in each layer. This works. Let's move on with this. Let's add more and more layers, or let's increase them, a couple of more neurons. So it's like the recipe changes. It's like a secret sauce. So OpenAI will have like a configuration we don't know. A Gemini has a configuration we don't know. Claude has one, no one knows. So it depends. And that's why like some models, some AI are better. For me personally, Claude is better than all the other AI out there in terms of reasoning and language. Then what else? Gemini is very fast. Gemini is good in overall, like it's an all-rounder. GPT is good in terms of length of the conversation. So it depends on their configuration. It's secret to every company. Yeah, you're welcome. Any other questions? Can I move on? Okay. Okay, I'm gonna move on. If you have any questions, just drop them in between and I'll answer. Yeah. Okay, yeah, so this was the approximate budget, financial budget for training GPT-4. And here's like a couple of sort of takes on I wanted to talk about different companies. So this is Sam Altman, you know him, CEO of OpenAI. And just to give a backstory of how OpenAI was formed, it was formed in 2015. I think 8 college dropouts formed a startup called OpenAI. Sam Altman stepped in. He decided to be CEO. So what they did 10 years ago was they put a very risky bet on an AI that would take 5-6 years to be accomplished. So the GPT you're seeing now came out in 2021, I guess, or 2022, 3-4 years back. But the actual training for GPT, the actual data collection, everything happened 7 years before that time. So in 2015. So the company is found with no current product. So OpenAI was stale and dormant for around 7 years before they released GPT. So this is what they did. So they, or rather Sam Altman, who was pretty famous by that point of time, raised around $1 billion US in VC fund or venture capitalist fund. So that's the fund that startups try and acquire to build or sort of scale their startup. So OpenAI acquired $1 billion worth of funds through other venture capitalists. And then what they did is they started their first round of building OpenAI. For the first 1 or 2 years, they were collecting data. And collecting data is a very tremendous, very hectic process. It's not easy because you have to scrape the internet. You're sort of loading the entire internet's knowledge into a single brain, and then you're going to release that. So that's your plan. So how do you scrape the entire internet? You have to sort of first get an idea of what the dictionary looks like. You have Wikipedia, you have Google search engine, you have Reddit, you have YouTube, you have a lot of forums, a lot of websites, Stack Overflow, this. So for the first approximately 2 years, they were just collecting data, cleaning it, as in removing any unwanted characters, making them into perfect rows of data, and then turning them into question answer format. So most AI models are trained in a question answer format. You ask it a question and it answers. And that's what they did. They had to build the data for that, a question and an answer. Now, once they had that, by 2018, they decided to, come up with a random architecture. It's called a transformer architecture, not completely random, but they had like some number, some idea of how, what number of layer or what number of neurons to use. And essentially what we saw earlier, backpropagation, they trained that neural network, that huge neural network via backpropagation on this very huge data set. I think it was maybe 45 terabytes of data back then. Trained it on that. The result was a very murky model. So the GPT back then, GPT-1, was not that smart. It couldn't speak proper English, was speaking gibberish, was hallucinating at times. So 2018, their first model failed. They tried again. 2020, GPT-2 came out. And in 2022, GPT-3 came out, or 3.5 rather. And that was like the first successful model that made it out large. So it took them like 3 attempts to get their first product out. And then from there, it is just optimization. And then from there, because they have 7 years of history or experience in knowing how to train or what data to train in what configuration. So OpenAI had like an idea of what to do. And then after that, it's been easy. They've been releasing 4, 4.1, and now we have GPT-5. So that's the story of OpenAI over the past decade. It's like a 10-year-old unicorn now. Yeah. This is Jensen Huang. He's the CEO of Nvidia. I think by this point, most of you might be familiar with Nvidia. May have seen it in newspapers or in the news channel or somewhere. So one thing I forgot to mention, or I mentioned slightly before, was this term called GPUs. And they are the ones that speed up the training process or the learning process of LLMs or ChatGPT. So this guy, he placed a bet too. So 30 years ago, 1993, around, I guess, this guy placed a bet, just like Sam Altman, on something called GPUs that was going to revolutionize gaming. And most of you, I think if there are gamers in this meeting or those who like use heavy GPU intensive softwares, you might be aware of NVIDIA's GPUs. They're very efficient for gaming and heavy 3D work or editing. So NVIDIA was built to recognize that domain, that department of gamers, editors, and like the likes. So for the first 10 years, up until 2003, they built GPUs purely for gaming. After that, they switched to something called AI. So around the time, like most of you guys were born, 2003, 2004, 2005, AI was just like starting to erupt. It wasn't really a term, it was just starting to erupt. So Jensen, the CEO, this guy saw that opportunity. He decided to open up a new wing to make or to manufacture GPUs purely for AI training. And these AI represents the neural networks, the images I showed earlier. So I think it's been there for like around 20 years. So for 20 years, NVIDIA has been perfecting the art of making very fast GPUs for training AI models. And after OpenAI came up, NVIDIA signed its like first million dollar deal with OpenAI, giving it GPUs to train the first GPT model. And then once everyone saw that GPT was the first step in LLMs, Gemini stepped in, Claude stepped in, Elon Musk stepped in. Everyone's now making their own AI models, but it requires some computer to run on, some chip, and that's called a GPU. Now, who's manufacturing the fastest GPUs on the planet? This guy, Nvidia. So now Nvidia has a monopoly on the entire training industry, training of LLMs, and they're worth. I think they recently crossed $4 trillion net worth in May. Yeah, and around I think 30%. No. Around 70% of their employees are millionaires. 70% of their employees are millionaires. Just to get an idea. So these same employees who are earning like 100K, 120K annual salary turn out to have a net worth of millions just because the stock in the company blew up. Like from 2021 to, you can just Google, Nvidia net worth over the past 5 years. There's a curve that goes from zero to boom to 4 trillion. So it's like a 5-year growth, very exponential. And they're the ones powering ChatGPT. So every time you open up ChatGPT or Claude, every time you press enter, the reason why you get a response in under 1 second is because these LLMs run on super fast GPUs made by NVIDIA. So they're the ones who are crunching all these neural networks and forward propagation, backward propagation, the data, everything, all in under 1 second. So yeah, a lot of stuff happening there. And this photo, this is a photo of a town called Abilene in Texas, in the United States. And this was a town. It was transformed into a very huge data center, part of a project called Stargate. Might have heard of it. Project Stargate is a $500 billion AI project. It started, signed by the US government under Trump's leadership, with Sam Altman, then Oracle CEO, a couple of other CEOs who are standing in as advisors. And it's in construction to be probably ready by 27. So what's happening in this photo is that it's over like it's a very huge piece of land. What they're building is a $500 billion data center to train the next generation of LLMs. And they're expecting this to be like one of the biggest fundings or biggest leaps in AI, because the trend we saw earlier, remember that meme, add more layers and your AI will become more intelligent. So the more layers you add, the more neurons you add, consequently you require more data, more energy, more GPUs to train it. And it's not one GPU, it's not 10,000, it's maybe 1 million GPUs. And you can only fit them in warehouses this size. So probably like 10 warehouses. So this is Project Stargate. It's under construction, ready by 27. Might be seeing some of the best AI out there by 2030. So maybe in the next 5 years. And it's a very incredible leap. Yeah. So these are like 3 sort of current affairs I wanted to like share with you, like the trending topics. Any questions on this? Anyone have any doubts, queries up until here? Okay. Okay. And then I'll move on to the next leg, the last leg of our workshop. Yeah. This is the current artificial intelligence market. The projections from 2025. So this is the trend. So from 2018 till 2025, the market is currently at $400 billion. So right now we're sitting on $400 billion, and the color-wise split up for different countries. And you can see that Asia Pacific has the largest market. Notice that this sort of slightly blue yellow bar, the one in the middle, that's the Asia Pacific market. So market here represents consumers and producers, and a huge portion of this market is comprised of consumers. So Indians, for example, we're like 1.8 billion population country economy. So out of that, a huge portion of it is contributing to ChatGPT's usage, or probably any AI usage. And we have China. So these are all part of the Asia Pacific region, and they're very huge consumers. Now, North America takes a smaller cut of it. Europe, an even smaller cut. Latin America, MEA, those are small. So the current standing is at 400 billion US dollars, and the market captures producers and consumers. Now, producers are the ones that build the AI. So OpenAI, Anthropic, Google, these companies. Then you have sort of semi-producers or semi-consumers. So startups or companies that build on top of this AI. So YC-backed startups, or one good example is Cursor. Some of you might be using Cursor as your code editor. Cursor is an AI-powered VS Code, and it's a very huge consumer of these AI companies. It feeds off of all these APIs, all of ChatGPT, all of Claude, everything. They also have a very huge consumer market. Means over 100 million people use Cursor, which means indirectly these same users are using ChatGPT, Claude, Gemini, and so on through Cursor. So that's another portion of the market. And not just Cursor, there are many other apps. So you might know about Versal, Lovable, Bolt, all these app designing, app creation softwares, websites. I guess there's like a lot of other examples to cite, but yeah, this is generally how the market looks like. So it's expected to blow up to over close to $2 trillion. And the reason why is that there's going to be more and more automation involved. It's not that the number of users are going to increase, but rather automation is going to increase. If you guys may be familiar with N8N, it's an automation tool in which you can stack together some pieces of logic and then create a completely automated flow that can maybe handle your emails or handle your phone calls, handle your WhatsApp, whatever. That's an example of automation where you automate things using AI. So instead of increasing the market, instead of seeing an increase in the human market or human user market, you're seeing an increase in the AI powered market. So you'll be seeing an increase in automation, a lot more of automation. The very simplest example of AI automation right now, apart from Cursor, would be Perplexity. Perplexity. Perplexity is an AI powered browser. It has this tool called Research where you can plug in your question or plug in a task, anything. It will do it for you. Like literally do it for you. You can share a PDF and say turn this into an Excel sheet. It will do it for you. It takes around 3-4 minutes to do its research, by which time it has automated a lot of things using a lot of AI. So those 3-4 minutes might seem like nothing to us, but it means a lot to Perplexity. They're burning through a lot of APIs, burning through a lot of automation to get your answer or prepare the answer the way you want it. So automation is like one of the next steps that we'll be seeing. And then the second industry taking over this market would be robotics, automated robotics. China is one of the forerunners in this field. Even for me, it's my LinkedIn feed is like populated with all of these Chinese robots doing random stuff, playing football, running a marathon, and so on. So these robots also rely on AI. They rely on computer vision, to be exact. And they're trained too. So they're trained on the same Nvidia GPUs that power ChatGPT. So that's another portion of the market that we could be seeing. And then again, below, you'll see other smaller markets for other startups, for other companies, smaller forms of automation, maybe for legal jurisdiction, for maybe smaller versions of it. But these two, automation and robotics, are like the top two markets that you could see blowing up in the next 2 to 3 years. So if you're thinking of like landing a career in AI, like rooted in AI, maybe try targeting these two, automation and robotics. And one person did ask me like, what's the influence of AI in content creation? So scrolling Instagram, I've seen a lot of reels with a portion of AI in them, like AI generated audio or AI generated brain rot, something. So that is also not necessarily a big market, but it's kind of new. Some reels, some shorts on YouTube, some videos themselves are 100% AI generated, which have got like a lot of views, but it's very rare to see them. It's not like AI content creation hasn't fully captured it, but it is there. It's still there. There is a potential for it. So people are using AI to create content. Good for them. It's a new space to be explored. Maybe that could blow up too. It could come into the top 3 as well. So this is like the current standing of the AI market as we see it. Now, if you are entrepreneurs or like you're aiming or aspiring to be one, or if you have a startup where you think you could bring in AI to solve a problem or a crisis, this is a report of Y Combinator's 2025 AI breakup. So just for a small understanding, YC or Y Combinator, it's an angel investor or a group of angel investors who invest extensively in startups that show potential to become a unicorn in the future. And they fund like very small startups. I think even from Kerala, 2 or 3 startups have been, no, more than 3 have been startup funded by Y Combinator in the past 5 years. All of them being AI or having an element of AI in them. This graph shows like the breakup of how Y Combinator, this angel investor, has been funding startups. So in the top row, the top bar, there were 36 startups who built vertical applications for specific industries. Vertical applications means if you're building something purely for one industry. For example, let's say robotics industry. One thing robotics industry lacks is the lack of label data. So if you build like a app that can label data for robots, that's a vertical application. Now there is horizontal application or for broader use. So for example, you have an AI-powered CRM that can cover or touch a lot of other industries. It could cover hospitals, it could cover banks, and so on and so on and so on. That's horizontal applications. There are 22 of them. What gets interesting is that as we go down this graph, we can see that there are 17 startups for tools, 14 for coding, 12 for sales, 8 for consumer, 6 for data science, and it goes down, 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 down. So right now, just looking at this graph, this top section, like the top 3, would be the trend that we're looking at now. Because everyone's targeting vertical applications, everyone's targeting some use case or a particular problem in the industry that can be solved with AI, just with AI. So they're not looking to generalize, taking AI to solve an already done problem or automate some already manual work. They're not doing it for that. Most startups now are focusing on one problem in one industry, like a niche problem, and then using AI to automate all of that. So when you do that, or when your startup does that, you're basically putting out a notification saying, "Hey, this was your problem. We solved it for you." Boom. And now you have buyers coming in. Horizontal applications, on the other hand, they're comparatively smaller, but rather you're targeting a bunch of industries with AI. Not one, but a bunch of industries who could use your application in a shared manner. So it sort of has a market. What's funny is that coding hasn't really caught up because I think Cursor has a monopoly over all AI code editors. So coding is sort of still at the bottom. And at the very bottom, you can see these 3: chips, video, and security for AI. The reason why video is at the bottom is because now we already have Veo and Sora probably taking over the market in video creation. Then there is InVideo, which is another great tool for video creation. And then security for AI, that's also a very small market. So where I'm working at, we work in AI security. I mean, security for AI, yeah. And chips is also a very small market. So these are not the chips you eat, but remember the Nvidia GPUs I'd mentioned. Those are semiconductor chips. So people who are working in this field, if you're, let's say, in electronics or triple E student or graduate, this is a very interesting area because Nvidia has a monopoly over the training industry to train LLMs. But other companies, smaller startups, are looking to dominate the inference or serving industry. That is, when you open up ChatGPT, how do you get a response in under 1 second? You had to create GPUs or chips that are very quick to serve users. That means your users should not see any gap or any latency between the question and answer. So I think a few startups are working on chips. It's a very risky move. They're building something for the future for the next 5-10 years, and they had to be quick about it. So yeah, this is the breakup of Y Combinator's 2025 batch. This is how it looks like. And this is, I'm coming to like close, not exactly close, but I've been discussing trends so far. Like towards the second half of this meeting, I was discussing trends about how things could change, the notion about AI could change, the notion about the market could change, the notion about how your startup could change. So these are just like sort of trends on how we could see the market shifting. So yeah, And I think I'd like to close it off with this slide, one slide. And I'm open to questions. If anyone has any questions regarding any of the topics I've discussed, feel free.
So we got two questions in the chat.
Okay. Okay. I didn't hear the notification. So, okay. So, what is super intelligence? Super intelligence. Yeah, it's a broad. It's sort of analogous or synonymous with AGI, a general intelligence. But it's something we're trying to achieve. So, if you notice ChatGPT now or any AI now, what they lack sometimes is knowledge. They might make up stuff, or they might not have information to it. Secondly, they might lack from conscience, sentience, and emotion. So that's the one thing that sets humans apart from AI, is that they don't have emotions and they purely speak on what they have been trained on. They can mimic. So if you ask it to like act like a person, they would act like that person. They would try and replicate emotions. But AI has not yet reached a level where it can answer any question. It can predict the future, or it can, create new innovative stuff. Or let's say it can act like a human, purely like a human. Not yet. One example of super intelligence is, if you've seen this movie called Her. It's a very good movie about this AI that's very lifelike. That is something that's super intelligent, because it's not only very lifelike, but it's yeah, it's pretty knowledgeable in most areas. I hope that answers your question, Muzamil. What about AMD? They aren't providing GPUs. Yeah. So the reason why you don't see AMD in the AI market largely is because Nvidia captured it first. So they've been capturing the AI market since 2004 or 5, like 20 years back. They've had that leverage till now. The way they did this was they went and spoke to actual scientists, actual researchers, and asked them, what problem can we solve with GPUs? And it was just one reply: how can we speed up neural network training? And so NVIDIA focused on that one thing. They sort of improvised to build GPUs that were faster than AMD at training. So while AMD still, they still build for gaming and build for GPU purposes, they just don't have a larger hold on the AI market as of yet, not yet. But they still, I think, in gaming they do have like, for super resolution they have, I think, FSR to improve resolution. That's like AI powered kind of. That runs on AMD. So that's a small portion they've been contributing. By the OpenAI Project Q. Yeah, I haven't heard about that. It's probably new. I'll look into it. My LinkedIn, yeah, I'll put it in the group after the meeting, so everyone can access it. Yeah. Any questions I left unanswered or open-ended? How could you use? Okay, how can I start building my own AI agent? So there are frameworks. You could probably look into OpenAI's agents framework. They offer like a complete suite of tools for building an agent that can perform not just chats, but also talking with certain elements of your laptop or system, whatever it is you've installed your agent on. OpenAI agents is a very good place to start. It can, a couple of like basic functionalities is like file search, web search. It has MCP too, if I remember correctly, which means it can manipulate your local files to talk to different portions of your computer. It's a good place to start. And then there is LangChain, but I wouldn't like recommend that completely. But definitely look into OpenAI agents. It's like one place you should start. They have a very good documentation. very good write-up of how to properly use agents, what model to use, how to optimize for speed, and so on and so on. Any other
Now,
question?
mm, yes, sir. Any other questions, anyone? Okay, so I think we'll wrap up the session. So I now invite Iron Sarah Vinod for the vote of thanks.
Good evening, all. On behalf of everyone present here, I extend my heartfelt gratitude to Mr. Alosh Denny for his insightful words and enlightening session on deep learning. Your valuable time and knowledge have truly enriched us, sir. The session was really informative and interesting, and I hope it will create an impact on everyone who present today at the session. I also wish to thank our wonderful audience for your active participation and engagement, which made this session a very meaningful and interactive one. Thank you all once again.
Yeah, thank you guys. Amazing audience, pretty good interaction. So yeah, thank you for being here. Awesome.
Thank you, sir. Thank you, everybody. Yeah, the feedback form will be launched in the group within an hour. Thank you.